Hello everybody and welcome to Game Development, or GDV. So that's a super generic term for this class, but hopefully you guys have already had a peek at some of the content. Basically, this class is treated as another, I want to say SCD3, but that's the new name. PGF3 was the old names. So it's another scripting class with a main focus on getting AI and some state patterns up and running and stuff. So we're going to have some navigation and all that all working by the end of the class. I'll get started today with just kind of showing you guys how FSO is laid out and talking a little bit about the class. In this very first assignment here, course materials and policies, there's a bunch of just general links and everything for this. When it's saying the Unity version right here, it's just saying update to the latest version as of the time that we were writing this. It was 2019.5. The latest version as of today, which I just downloaded, was 2020.1.14 F1. As long as you're on any newer version, newer than 2019.1.5, you'll be good. And in regards to a very specific version, don't worry about that much. There's a reason for that. Next up, there's links in here. As I was saying, it's just general things. There's the course materials, which is a Google Drive with everything kind of laid out similar to how it is in FSO, with the weeks broken down for each of their content. If you need a reference to that, there are links in the assignments themselves. But here's the general link. Make sure you check out the different policies for this class. I do want to talk about that though, because and that was not the policies folder. Interesting. That's a broken link. Well, whoops. In here, there's a policies folder. And in the contact policy, many of you have probably already noticed that the class Discord is not up for this month yet. And that is because Discord decided to do an update that broke our bot to allow actual tagging and setting you guys up for the classes. So that'll be down until Thanksgiving break. Unfortunately, there's not a lot we can do for that. It does state in here, like, do not direct message through Discord unless requested, and normally post in the class channel, but we'll disregard that for this very first week while Discord is down. You feel free to direct message me or your instructor. I'm actually Justin Murphy. Don't think I actually said that yet. Sean Kendall would probably be the other teacher for some of the online sections. And Sean Paris will be the lab specialist mainly for this month. So feel free, not Sean Paris, the other Sean, who's not on here. Damn it. Sorry about that. I'll have this updated and I'll be sending out an announcement as well shortly after this lecture finishes about how you can contact us and things like that. Just wanted to point out that you can disregard this rule for this very first week. So moving on, there's a link to the live sessions, which it appears the majority of you have already found if you're here. And these are the sessions. We're going to be meeting every Monday and Wednesday for these next 4 weeks. And just a link to join. Lab sessions will be held at 7 p.m. Those will also be the same days that you guys have lectures. So feel free to join that once that join link has been updated to the newer session once I get that set up. And then there's also recorded lectures. So every lecture session will be recorded and they'll be posted down at the bottom of this playlist for this month. Feel free to check back through. It does have some previous month's recordings. If you want to just catch up on something or you weren't able to make it to anything, feel free to check out those different lectures. And somebody's joining. So moving on from the recorded lectures, make sure you check out all the policy documents, and then Discord will have that channel back up and running back up on Monday of next week. So that's the course materials and policies. Intro assignments, you guys should be used to these. Just the basic professionalism, course overview, which is basically what we're doing now. It's just going to be an explanation of what the class will cover, and contact info. Then we get into the actual weekly content. As you can see, we've broken it down per week about what the content will be. Week one, we'll start off this week pretty easy. We're going to do a bit of a review stuff and then introduce you to the concept of dictionaries for today. So we're going to be covering these first 4 sections. Okay. But yeah, we'll be covering these first 4 sections just kind of as a quick review if you need a little bit of brush up from scripting, since I know your last class was quite a while ago and might need to touch up on some of the basics again. And then on Wednesday, we'll actually be breaking into the navigation system, covering some of that, and as well as briefly taking a look at checking out the state pattern, which is going to be a main focus. It's a programming technique that's commonly used for just any software development. They refer to them as as different patterns or design patterns, and we'll be covering that heavily throughout the month. We'll be just briefly intro to it for this first week and digging a lot more into it for the future weeks. Oh, and looks like my well, that's fun. Looks like my internet cut out there for a moment. All right, so for week one, we'll be talking about starting it off pretty easy. We're going to be doing a bit of review stuff, taking a look over some of the basic scripting stuff. And then on Wednesday, this lecture, we'll actually be breaking into the navigation system and digging into the state pattern. The state pattern, or design patterns in general, are commonly used in software engineering or programming. And it's something that really helps when you're working on bigger projects and things like that. You'll notice these different patterns, and well, a lot of other people have noticed them as well. So they've come up with a lot of really good solutions, and we'll be digging into that heavily throughout the month. So just a brief touch on that and intro for the end of week one here. But then in week two, we're going to be doing a bit more of a review. We're going to be looking at some intermediate scripting stuff. And then we're digging into kind of putting that state machine use to practice and digging into or building on that same topic of getting more advanced and actually analyzing games and trying to break things down in a state mindset. And then we'll be actually providing you with a state machine. So you'll be getting experience of working with someone else's code and actually putting that to use, which is something very, very common on pretty much any game project, unless you're all right. So apparently cut out when I was saying we're putting it to practice with this nav agent state machine, and we'll be providing that to you, as well as giving you experience with working in someone else's code base and things. And no, I'm on Bright House or Spectrum nowadays. All right, moving into week 3 is where the fun actually starts. So we've been building up on these topics. We've been learning kind of little small things that we can put them together with, and really digging into this. And week 3 is going to be your project week, where we put everything all together into a project we like to call Sneaky Sneaky. Here's an example of a finished Sneaky Sneaky project. The goal of this is where you have this player where he'll try and navigate through a puzzle-like maze and get to an end goal. And he has to try and avoid these different guards that are patrolling between these different patrol points. If we actually take a look at this, as you can see, the guards immediately just start going to their different patrol points. They're changing to different colors. That indicates what state they're in, so we can have that clear feedback. And they'll just patrol between their simple points. Our player, if we click, it will walk around and go to the point we're actually clicking. So our player is also making use of that navigation system rather than just trying to run straight at the wall and running into the collision and sliding around or something. But as far as these guards, if we actually get near them and get within like an aggro radius, they'll start chasing us. And I've tweaked this level so it's easy for my player to like get away. Once I get away, oh, gotta sneak around him. And we also have no lose conditions, so it doesn't matter if the guards touch me or have seen me for a period of time or anything like that. But so they'll actually respond to the player, get pulled off their normal patrol route. Once they lose sight of the player, they just go back to normal patrolling. We have another functionality where we're able to select the different guards and issue them different commands. For example, if we had like a stun effect, we can pause that guard in place for a period of time and then unpause it. We currently have this set up as just a quick debug press, where if I press 1, it'll tell it to pause, and I press 1 again, it unpauses, because we need to be able to test this rather quickly and get you grades on time. Thought you were following lines. Are there any using lines, or are they all of them using the blue part? Oh, so the blue part you see over in the scene, that is actually the nav mesh itself. The mesh part is actually these division of polygons. That's not the part they're following. The part they're actually following, if I go ahead and select this guard, and I have my navigation up, and with this on, looks like I have my gizmo off. Nav mesh agent. It's actually the navigation system itself is shooting out a bunch of different lines. There's this dark gray one, might be a little hard to see, going straight to that objective point. Then there's a few other ones detecting obstacles around it. And so that's the actual path they're following. I also have it showing which path polygons it's got to go through, and that's kind of how that navigation system works. And it does it all there for you. And you really only need to have that debug on if you're trying to track down an issue, like why is it going over to the right when I told it to go over to the left, and things like that. But as I was continuing on, we'll just leave that on over in the scene. Certainly. And we'll be covering that quite a bit as we get into the nav agent navigation system a bit more on Wednesday. I mentioned that we have the ability to press the right arrow and select these different guards. So if I select this one, we have other different states or commands that we can issue it. There's a reverse command where it'll actually reverse and go backwards through its navigation points. And then there's another one that I like to call a distract technique, where it'll pull the guards off and away from their actual path, where they have a certain point in the level. I pretend that my character has like a little tablet and can remote hack a terminal that calls the guard over, the guard goes to check it out, and then returns back to normal. So that's another technique we can use to just tell the guard to go over there so I don't have to deal with them anymore and get past. And then the end goal, of course, is to just escape the level, which for this level isn't too hard because my players should be a little bit faster than the guards. That guy's fast, dang. Well, guess he's gonna follow me to the goal. They're all chasing me. Might not make it. And once you make it, you get a little win title and hey, yeah, totally good. Just 3 guards all surrounding me and pushing me around. But I escaped anyways. All right. So that's the idea. We're going to try and put this to practice in this little demo here. I don't technically call it a game because it's game-like, but doesn't have the actual finished product of like a lose condition or the win condition isn't really well thought out or things like that, but demonstrates all the things we've been learning up to this point. Back into the content on FSO, the very last week of stuff, we'll be talking about animation systems. So animation systems use that state pattern to make use of a couple of their concepts and how that all works. And Eugene, I will answer that one about multiple nav meshes next lecture when we are talking about the nav meshes, because we have a bit more content to get through today. But our last week is more of a self-study week that's going to talk about the animation system, relate it back to all the topics we've learned, seeing how we've set up our own state machine system where our behaviors are now using the state machine versus just doing it in the animation system. And walks through a little bit more advanced topics just to get you prepped up for final project, which you guys have coming up in a few months. All right. So any questions about the layout of the class, or should we dig into the first half of the week 1 stuff today? Ask a question before you get off. Discord channel, I answered just before you had joined this session. It is in the recording, but I'll go ahead and say it again. This very first week, I'll not be able to give you a GDV class access until that bot is back up and running, and Discord had an update last night, which I found out decided to break the roster config. So that will be fixed after Thanksgiving break. Let's dig into the week 1 stuff. So week 1, we're just digging into these first 4 assignments right here, some basic Unity review. And we have Unity scripting. And in here, this is just another quick demo getting you caught up on the basics. We're going to run through some of the basics as well, just some arrays, loops, and basic things just to get you back caught up to some basic scripting levels. So for this, I'm going to go ahead and open up a new project. I'm going to use the newest version of the engine that's not an alpha or beta release. And we'll just give this a project a name, GDV, and this is 2012. And let Unity load. So while Unity is loading, I do want to mention that some of the materials and things like that, or tutorials you're following along, are written in an older version of Unity. This is done on purpose so that you can get experience of trying to decipher what the newer version, or using older tutorials in a newer version of engine, how that works. And we'll be digging into that topic throughout the month. So keep in mind, even though some screenshots may be a little bit out of date, that is on purpose. So newest version of Unity, up and running. We'll just go over some basics. You guys know that this is the scene window, this is the game window, this is the inspector, all that stuff. So we'll just dig into it. We need a script to run here, since this is a scripting course. We'll right click in the assets and we'll just create a new script for us. Got to give it a name. We'll just call it basics. And let Visual Studio load up. All right, and we got everything highlighting and all that. If it is not highlighting correctly or anything like that, or you see miscellaneous files up here, I'll be sending a link out in the announcement later today to show you a couple of steps on how to fix that and get Unity and Visual Studio talking back and forth to each other again. So we've got a class here that it came with, named the exact same thing as the script. That's important. If you don't have a class named the same as the script that also is inheriting mono behavior, it will not be able to be attached to an object in game, in the engine. And then we have a start function and update function, which you should all be quite familiar with already. If we wanted to, let's say, do the very basics of printing out hello world to the screen, well, in here, we'd want to do it inside one of the functions, since that's where executable code can actually run. Let's add debug.log. And debug.log is just a print string, essentially, that also goes to another log on file. And we can print out anything we want. Hello world. Every programmer's first program. Give that a quick save. And in Unity, and I went to the wrong Unity. I'm going to close this one out since we're done demoing that project and go to the other one. Our console is where it would print out our debug logs. If we just press play, we don't see anything printed. Problem is, a script, when you're creating it, is actually a component. Components have to be assigned to game objects. Your scene itself only has game objects in it, and they're composed of different components that make them up. For this, I'm going to just create a new empty game object. I'll also call it just basic. And we're going to attach our script to that object. Now with that script attached and our console showing, we do get that print. I do want to point out that down here, it actually gives us a lot more information than just the timestamp and what function caused it to print. It actually has the text, what function was called, and what other function specifically in our assets was calling it. We should be able to even click that and go directly to the script to see where that log, or what caused that log to happen. All right. So basics, as I mentioned, we're going to move into a little bit more. Let's go ahead and add a variable for this. So there's a couple of different types of variables you can have inside a class. There's something called member variables or fields that you would have at the class level here. If you're doing a variable inside a function, that's generally called a local variable. And so let's add an int here, and let's call it number. I'm going to give it a value, and we'll just say 3. And Visual Studio's complaining because it's assigned, not used yet. Well, yeah, we haven't done anything with it. And rather than printing out hello world, I want to print out the value of that number. So let's just put in that variable name here. So when you're declaring the variable, you have to have the type of variable, name of the variable, and give it some sort of value. If you don't have that value ever assigned, it will come up with what is called a default value. And as we can see, use of unassigned local variable number. If I had number outside of this class, or outside of the function, and we try and compile, which I don't know if you're aware, but you can do Control-Shift-B to compile in Visual Studio right here. And you can see your errors right here rather than having to hop over to Unity and see them there. It's never assigned to and will always have a default value of 0. So that is just warning us, letting us know that that might not be what we intended, but it does let us use it. Another thing I want to talk about real quick, if you do get this all messed up with your tabbing and stuff, quick fix for that, holding Control, pressing A to highlight everything, still holding Control, tapping K then F will do an auto format. It'll format everything you have selected and put it at the correct tab structure so that it's nice and organized, easy to see where things are belonging. So we now have this printing out a default value. Let's make sure we do assign it. It's generally a good idea to always assign variables to something, even if you're assigning it to null, just so that the compiler knows that's exactly what you want it to do. And it's letting us know another message in IntelliSense is getting too advanced. It's letting me know that we don't need this because it's empty, but that's fine. We'll ignore that message for now. I just want to make sure it does print out the number 3. So we press play, and our console, we've got 3 showing. Fantastic. Let's add a little bit more complexity to this. Let's add some actual input checks and change this value at runtime. So inside our update, let's go ahead and if an input key was pressed, input, get key down, key code, and we'll just use alpha 1. That'll be the numbers right above our keyboard. Not to be confused with num1, that's on your number pad over to the right. When we press the number 1, we'll go ahead and tell that number variable to increase by 1. Number plus plus. Plus plus is the increment operator, which I'm sure you guys have probably seen before, but just in case you haven't, basically what it is, it's going to give you a number equals number plus 1. We'll give that a quick save. Hop back over to Unity and give this a play. Now we see 3. If I just press 1 right now, nothing's happening. If I click the game window, I don't see anything happening. I'm pressing 1. I've been spamming it for about 37 times now. If we look at our basic script, we can't see that number either. One thing I want to point out, you can actually change the inspector into debug mode. You can right-click on it on the tab, switch over to debug, and you'll be able to see any private variables you might have, with some exclusions for complex lists and things. But we see that number now has a value of 62. We didn't get another print because we never, well, told it to. We only told it to print back and start. And I did have it apparently pressed 61 extra times. That was a bit off on my guess. But now that we know that that number's changing, we also want to print it out to the screen. So we're going to need to add another debug log whenever we're changing that number. Because update is running every frame. Start just gets called when the object first gets spawned into the level. And since we have it attached to an object in the level, it's at the very beginning of the game. All right, so we've got basics changing and updating, and should be able to play. And now whenever we press it, we do see that. And we do see the line of code that it was changed on, or that print was happening on. All right. So that's super basic still. Let's move into more complex type, and let's do an array of something. So this is just a single variable right here. If I wanted an array of integers, we can define that by saying what type of variable we want in the array. That's going to be an integer, and we need to tell it an array using the square brackets. And then we can give it a name. We'll call this number array. Now, defining this is going to be a bit different. I can't just say equals 5, and it might actually let me with the basics. No. So for this, you can assign arrays with a comma separated value inside some curly braces, such as this. So that would give us an array of 3 items. But let's say we wanted to see this array in the editor and actually assign it there. Because when you're tweaking values, you shouldn't have to jump into a script and change this from 25 to 24 here. That should all be done while you're in game and are able to test it and things like that. And while we can see these in debug mode, we can't change any of the items. That's due to the protection level of these variables. By default, anything inside a class will have a private protection level on it. So by saying just int number, that is the same as saying private int number. And that means only this class can see it. No other classes will have access to this variable or anything like that. If we wanted to, say, change that, there's 3 protection level types. We'll just be talking about public and private today. Public means, yep, it's open. Anybody can change it. So by making it public and hopping back over to Unity, we now this is no longer grayed out, and I can actually change that right here. Any values you enter in the editor will actually overwrite the default that it was told in the script. So keep that in mind. Precedence in the editor itself takes precedence, essentially. One other thing I want to point out is if you did want to expose this to the editor, but not necessarily every other class in your game, let's say, for example, your character has some health on it, and your HUD would want to know that health or something, but doesn't quite need to have direct access to it or shouldn't be able to change it, you can keep that field private here, but you can add a tag of serialize field to allow the editor to see it, and that allows the compiler itself to know, hey, I want to serialize this field so that the editor has access to it. And so even though it's private, we still have that same level of access just like it was public here. All right. Next up, let's actually print this array. And for this, let's take a look at creating our own function. So we've been using some built-in functions like debug log, start and update were already here for us. But when we're defining a new function, we have to first say what we want it to return. So very first thing you do, what return type will this function return? I'm going to have this return nothing, or I'm going to void that return type. And then we got to give it a function name, our function. Then the next part to this is something called the parameter list. We see those parentheses anytime we've got these functions defined. These are taking in no parameters. This is where information you can say would be passed into this function. If you have some extra variables you need to know, for example, if you're doing some calculation that needs to know a target, you could pass that in to the parameter list. We don't need any parameters for this. We'll just be printing out our array in here. In fact, our function is not a very good name. We'll call it print array. And then we gotta put any code we'd like this function to run right here. We'll do this. We have 3 numbers. We'll do number sub 0 to get that first variable out of the array. And I want this to print out, so we'll put that in a debug.log. And we want the number array, not just number. And we can do this 2 more times for each index of the array. So this very first number I have right here is actually going to be considered index 0. Our next one would be considered index 1 and index 2. That's something to always keep in mind. Arrays count with 0 as the first item in the array. All right. So that should print for us. We'll save this. And we'll give this a play. And I forgot to call the function. So I wrote some functionality in a function, but we weren't ever telling this function to run because it wasn't in a part of the game that runs, or nothing told it to call this. You see, as we're looking at this start and update say that they are a Unity message. Unity actually calls these messages for you. So that's how they get told to run. If we want our function to run, we'd have to put it somewhere where we tell it to run. Let's just have it run in start after it prints just that normal number. In order to call a function, you use the name and specify what parameters you're passing in, or arguments. So we'll tell it to print that array. So we press play, and we get 3 printed first. That's the value of number. Then we get the actual array values, which we see right here, 3, 24, and 1. Now let's take a look at this, and let's say somebody comes in here, decides they want 4 numbers in this array, and that 5th number will be 525. If we try and play this again, our print array function didn't handle that. Well, that's because we only told it individually, I want that first item, I want that second item, I want that third item. It doesn't even know about that 4th item. So if you don't know how long your array is going to be, or even if you do, there's a much easier way to write this than having to do each individual element at a time. We can use a for loop. And yes, length. So we'll use for. This will actually cause our code to loop based on certain conditions that we need to specify inside here. And did I actually see that? Fill that out? Oh no, just giving me errors because I haven't done it yet. So for loop has 3 parts inside the condition portion, and they're actually semicolon separated. The 3 different parts to it, and for loops also have a body. This first part gets run before the array before the for loop does execute or anything. So this is where you can initialize any counters or anything like that that you'd want for the array, or for the for loop. Just feels weird saying for twice. Intended for use in the for loop. We'll go ahead and create a counter here. We'll just call it int. Very commonly, we'll often see I used for this because it's iterating through the array I. It's also associated with index because for loops are very common for indexing into things. And we'll initialize it to 0. So we've got our counter. The second part of this for loop section is the condition. This will say how long it'll loop for. And what it'll do is it will execute the code in here until this condition is false. Well, I want this to loop to the end of the array. So we use our counter. We'll say as long as I is less than the end of the array, which our current length of the array, length is 3. Oh, always do that. H before T. We could say I want it to loop 3 times, but we'll run into that same problem we just had before where I might not know the length of this array. So we'll just actually ask our array for its length. We'll ask our array for the length. So we're not going to be hard coding anything. We're actually using the values of variables to determine things instead of just typing in a constant. This last part gets run after it's executed the code here and before it goes back up to check the condition and execute it again. So this last part, we'll want to make sure we'll go ahead and update our counter. We'll say I has finished 1 iteration. We're going to update that, go to the next one. Then I we can come in here and we'll go ahead and do that same debug.log, but rather than using that hard-coded index into our array, we'll be using the variable that we've created, the counter, since that's changing each time this is going to loop. All right. Save all that. And now if we just go back and play this again, we should see however many prints or how many ever elements we have. So let's go ahead and change this to, say we have 500. Why not? We'll now have, oops, let that actually rerun. It says we only have 5 messages, but we've gotten this same message 497 times. I currently have collapse on, so it's collapsing the same message it detects over and over into just a counter over on the right. All right. So that's the basics of how you can create variables, assign variables, check for variables, iterating through an array, for loops, and how we can modify variables and things like that. Let's move on from, well, still kind of basic, but moving on from just the super basics into the data structure called dictionaries. You will still want to run through this experiment as it's defined, but I just want to run through another example for it so we can take a look at it while we're live here. So this experiment will use dictionaries to set up a zoo registry and track different animals, animal counts as time goes on or a button's been pressed to progress the different days, and animals be birthed, some will die. Sad times, but circle of life, I guess. Anyways, let's move into this concept of dictionaries. Dictionary is a data structure that actually uses, that combines 2 items. You've kind of set up your own dictionary in a way, much like a normal dictionary. You have like a word as a lookup or a key, and then it gives you a definition of that word as its actual value. That's why it's referred to as dictionary. It's a way to pair 2 things together, a key and a value. When we're looking up at this top, which I haven't talked about yet, these are some using statements. These top 2 are grayed out. They came with the script, or typically come with a script. If it doesn't, try recreating the script. But these are just some common things that people use. For dictionaries, they're actually inside this systems collections generic namespace. And so when we go to create one, this is a type of variable for it. We can say dictionary, and this is what is referred to as a templated type. These little angle brackets indicate that it can vary and have other types passed into it. It's a storage structure, so it doesn't know what type of things you're going to store into it. So we'll go ahead and use that. And we have to specify what type of dictionary we want. What kind of keys are we going to store? What kind of values are we going to store? And these can be literally anything. Most common one you'll find is that you'll use like a string for a key, and then the value will be something of purpose, whether that's a float to indicate like a stat. Let's go ahead and create like a stat set full inside here, this dictionary. So we'll be storing strings and our values. Let's have them just be floats. Oh, which I didn't circle back to. I was mentioning that you guys kind of created one of these already way back in PGF1. If you guys remember the text adventure assignment, you guys had to create something called a page, which made up a book. And what the page did, its purpose was to pair a heading along with the actual text that you were going to display. So you were creating your own lookup table in that version. This is a built-in lookup table for you. As you can see, the suggested values or suggested names are pretty awful, but it's about pairing things together. We'll go ahead and just call this stats. And when you are creating a non-standard type, like dictionary would be considered, if you have to declare a new class, declaring these ints and stuff, you don't need any constructor or to dynamically allocate it. But when you are doing a class declaration or creating a class variable, you have to initialize it using the new keyword. And IntelliSense popped up already with what type. And we're going to call that object's constructor. All right. Oh, and somebody already used it. Nice. All right, we've got stats. Now, we have to populate this array. It's going to be a bit different than just saying equals a few different numbers, because we're now pairing two object types together, things like that. And our start would be a great place to initialize this or add things to this array. Oh, nice. So we'll go ahead and populate that for our stats. And in order to add things to it, there's an add function. When we're adding something, we have to specify or pass in what key and value we want to add. Well, we'll pass in strength for our key, and the actual value we want, well, let's say 500 strength. All right. I'm going to comment out our other prints that we have just for a moment, so I can try and print one of these items from this. We can do print, debug log. Debug log. If we ask stats and access it just like an array using those square brackets, we see this is just asking for a key. We have to pass in a string rather than an integer for, let's say, just a standard array. We have to pass in that key value that we used. If we want to print the strength, we have to tell it the string of strength is the key we want. Can you populate the defined dictionary from an external spreadsheet? Yes, you could. It would be, depending on how good your code is, it might take a little while, but, and missing an R in strength. Thank you, sorry, I was reading chat here. But luckily your message popped up right after. All right, so that'll give us a stats, strength, and actually I kind of liked it with the R missing. We'll see what happens if we're passing in the wrong key. Just so we can get used to seeing errors using the tools available to us. Key not found exception. Given key was not present in the dictionary. well, where was this happening? Well, it was way down here. Our code was at basics line 27. Right here. Hey. There we go. Now we've got that right. Pop back. Give this one more run. And we get 500. All right. So let's say we wanted to do more than just print one number and add just one number and things like that. Let's go ahead and add a couple more numbers or a couple different stats. So I'm going to just duplicate that line a few times. We'll strength, mana, and health. Our health